Okay, g of x equals that function for x is greater than 1. Find the inverse function. So remember, for our inverse, we let y equal 3x plus 1 over x minus 1. And then we rearrange that to try and make x the subject. So if I multiply up by the x minus 1 and then expand my bracket, then move any terms that contain the x onto one side. So what I'm going to do, I'm going to add the y across to the right hand side, and then I'm going to subtract the 3x from both sides. So now I've got all the terms containing x on one side. Because there's more than one, we then will factorise and then divide both sides by the y minus 3. So that means we've now made x a subject. So our inverse function, therefore, we then interchange the x and y. So it will be 1 plus x over x minus 3. So that's our inverse function. Part B asks us to find the range of the inverse. Now the range of the inverse is the same as the domain of the function. And that's key to remember. The range of one function is the same as the domain of the inverse of that function. So the domain of g of x, well, we were given that in the question. We were told that function only exists when x is greater than 1. So if that's the domain of our function, that will be the range of our inverse. So for our inverse function, we found it to be this function here. And the range of that, g to the minus 1 of x, can be any value as long as it's greater than 1. So the range of our inverse function is the same as the domain of our function. Part C, state the domain of the inverse. So the domain of the inverse, is the same as the range of the original function. And the best way to get the range of any function is to sketch a curve. So to find the range of this, sketch a graph. That's the best way to get the range of any function. So on the next page, we're going to sketch our graph of our function. We're going to sketch the graph of g of x in order to find its range, and then the range of that will be the same as the domain of our inverse. So our g of x function I'm going to write up here. So g of x equals 3x plus 1 over x minus 1. So we need to try to sketch this so that we can get its range, and when we've got that range, that will be the same as the domain of the inverse. So the best way to get this, now when you do one of the earlier topics later on, you'll learn how to split this up, but this is called an improper fraction, and it's improper because the power of x in the numerator and denominator is the same. So what we need to try to do is split this fraction up. Now for the moment I'm going to show you how to do that, but you will cover it later on. So what we want to try to do here is split it up into a whole number plus some other number over the denominator of x minus 1. So what we want to try to do is split our fraction up so it's written in this form instead. That's going to help us to sketch it. So if we look at the right hand side of this, to add two fractions together, we would need to have the same denominator. So to turn these two fractions so they're both over the same denominator, I would need to multiply the numerator here by x minus 1. So if I multiply the numerator and the denominator by x minus 1, I've created an equivalent fraction. The second fraction is already over the denominator of x minus 1. So these two are no different. The right hand side of both of these are exactly the same, because effectively we could think, well, we'll cancel that and that would take us back into this form here. So let me just take those parts out. So what we've got there, and we know that's equivalent to 3x plus 1 over x minus 1. So what we can now do is join our two fractions on the right hand side together, because they've both got the same denominator. So we can now add their numerators together and put it all over x minus 1. So if these two are equivalent to each other, they've obviously both got the same denominator. That must mean their numerators are equal to each other. So let's say we chose the value of x to be 1. The reason I'm choosing x to be 1 is this bracket would then become 0. So it's just easy to work out. So if I choose x equals 1 and I put it into the left hand side, I'll do 3 times 1, 3 plus 1 to give me 4. And that would then be equal to, if I choose x is 1 and put it in the right hand side, that bracket will be 0. So that must mean that the b value would have to be plus 4. If I choose another value of x, now there isn't really a one necessarily that's worth choosing this time, so I could choose x as 0 if I wanted. If I substitute x as 0 into the left, I'd have 3 times 0, 0 plus 1, and I'd get 1. And if I put 0 into the right hand side, I would end up with minus 1 times a plus my value of b. But I already know I've worked out b is 4, so I've got 1 equals minus a plus 4, so that means that a must be 3. So I've now worked out the value of a and the value of b. So that means I can change this function, which was my g of x function, I can rewrite it instead as 3 plus 4 over x minus 1. So I've just rewritten my original function g of x in a different form. This is the one I'm now going to try and draw a graph of. So I'm going to use my transformations of graphs in order to try to draw that out. So I'm just going to take this part out so I've got a little bit more space. Okay, so we've got to draw this graph. So we're going to build up from our family of curves. We're going to start off by thinking, what does the graph y equals 1 over x look like? Because we've got some function which has a denominator with an x in it. So y equals 1 over x, we're looking at, and we were told in our original function that x had to be greater than 1. So that domain still holds in this case. So we're only looking for x is greater than 1. So our graph is going to look something like that. That's our graph y equals 1 over x. Then we think, what does the graph y equals 1 over x minus 1 look like? Because look at what we're trying to achieve at the end. We're trying to achieve something that's over x minus 1. So that shifts our graph. And that shifts our graph 1 unit to the right. So there's now going to be an asymptote here, because originally the y-axis was an asymptote. There's going to be a line there, and our graph has now shifted 1 unit across there. Okay, then we build up to our next one. We now want to draw y equals 4 over x minus 1. So that just makes our graph back in the second one, the one we've just drawn, that's going to stretch up and make it a little bit steeper. effectively the shape is still the same. So that line is still there at x equals 1, and it's just going to look a little bit different perhaps in shape. The x-axis obviously is still an asymptote. Then the last thing we need to do is now add the 3 on. So we're now drawing y equals, taking our graph we've just drawn, and we're going to add 3. So that shifts our graph up 3 units. So that means our x-axis is no longer an asymptote. Instead, it's going to be the line running across here, which is the line y equals 3, because everything has moved up 3, and we've obviously still got this asymptote that we had before, which was the graph line x equals 1. So our graph now looks something like that. So we've now drawn our graph. This is g of x. This is our function g of x. And we remember we're trying to find the range of our function g of x, because that will be the domain of the inverse. We're only looking for x being greater than 1, and that's okay on our graph. So looking at our value for g of x, we can see g of x, well, the graph carries on indefinitely up here, but obviously it stops here. It can never get to the value of 3. So that's going to tell us that g of x will always have to be greater than or equal, sorry, not, it can't be equal, just greater than the value of 3, because it never actually ever touches that line y equals 3. So that's the range of g of x. Therefore, the actual question asked us to find the domain of the inverse. So our inverse function that we had back here, our inverse was 1 plus x over x minus 3. And the domain of that is x is greater than 3, the same as the range of our original function.